Colby, 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 math.com.
Today in class we used two different models to identify factors of numbers. The UT model let us identify factor pairs, and we could identify all factors of a number using that model. We also used factor trees to specifically identify prime factors of a number. And so we have 12, 36, and 60 in this problem. These are all composite numbers. We learned the fundamental theorem of arithmetic says that all whole numbers greater than 1 are either prime numbers themselves or a unique combination of primes. And so when you take a composite number like 12 and you decompose it into its prime factors, you'll always identify the same unique combination of prime factors for 12. 36 has its own unique combination of prime factors. We'll see that here when we do these factor trees. You can start with any two factors of 12 other than 1 and 12, because of course if you start with 1 and 12, while those are factors, you have not decomposed 12 at all. You still have all of 12, and so any other two factors of 12, 2 times 6, 3 times 4, 4 times 3. And so I like to start with 2 if 2 is a factor, because that's the smallest possible prime. And when you identify a prime factor, you circle it. So 2 multiplied by 6 equals 12. There's also no need to put a multiplication symbol here in this model because we're identifying factors of the numbers, so by definition they're being multiplied together. 6 can be decomposed into 2 multiplied by 3. And so the prime decomposition of 12 is 2 times 2 times 3. In expanded form, we would write 2 times 2 times 3. If I wrote 3 times 2 times 2, that would also be correct, or 2 times 3 times 2. I just like to write them in ascending order because then it makes it easier to write the exponential form, which of course exponents are just a shorthand way of expressing repeated multiplication. And so if I have two 2's, that's 2 to the second power multiplied by 3. If I wanted to show an exponent for the 3, I could put a 1, 3 to the first power, but we don't usually do that. If there's no exponent showing, it's 1 by default. I also want to take a second before we move on to the next ones and show you 12 done a different way. If I had made a different choice, like 4 times 3, in that case I would circle this 3 because 3 is prime, but then I would decompose 4 into 2 times 2. And then you see that we end up with the same thing, 2 times 2 times 3. That's what we mean by every number is a unique combination of primes. 2 times 2 times 3 is uniquely 12. Why don't you try to do 36 and 60 and then express them in their expanded and exponential forms during the pause, and then come back and see how you did.
Paused.
.36, I'm going to do 2 multiplied by 18. Circle the 2. 18 is 2 9s. And 9 is 3 3s. So for 36, I have 2 multiplied by 2, multiplied by 3, multiplied by 3. In exponential form, that would be 2 to the second power, or 2 squared, multiplied by 3 squared. 60 is 2 30s. 30 is 2 15s. And 15 is 3 5s. So that prime decomposition or prime factorization of 60 in expanded form is 2 multiplied by 2, multiplied by 3, multiplied by 5. In exponential form, it's 2 to the second power, multiplied by 3, multiplied by 5. I hope that helped with the assignment. I'll see you tomorrow.